All right, today we're going to be looking at the hyperbola, which looks like this on both sides. Let's get to it. It's the shape that looks like the opposite parentheses on the title. That's what it looks like. Our keywords are center, foci, vertices, transverse axis, and conjugate axis. The equation, or the two equations that we're going to use, is x minus h squared minus y minus k squared. The x is over a squared, the b squared is under the y. In this case, you are going to have a hyperbola that opens left and right when the x is positive and the y is negative. So the other way you can see it is y minus k squared over a squared minus x minus h squared over b squared equals 1. And because the y is positive, it's going to open up and down. Now the only difference between these two is that with one of them the x is first, with the other one the y is first. You'll notice that a squared is under the positive one, whichever one is positive, and that's going to be basically your transverse axis, and the negative one is going to be what's called the conjugate axis. So let's look at these individually. So when the y term has a minus sign, when x is positive, the hyperbola is going to open left and right, as you can see here. Now here's why. The center is HK as usual, and A is going to be this distance from the center to the vertex. Now when A is under the X, that means you're going left and right, which is why it opens left and right, because that's where your vertex is going to be. B is a distance from the center to one endpoint of the conjugate axis. And that conjugate axis has really one purpose, and it's to draw this box right here. You see this dotted line box? Well, the box, the sides of the box, are at the vertex and at the end of the conjugate axis. The reason we need to get this box is really for these diagonal lines. What these diagonal lines do is they give us a reference for how wide our hyperbola should be. These are asymptotes, so those are lines that your hyperbola are going to approach but not touch. So once you're done drawing your hyperbola, your lines should go through the vertex and approach these asymptotes. C is the distance from the center to the focus. The vertices and foci lie on the transverse axis. So wherever your vertex is, you keep going that direction to get to your focus. The foci lie on the inside of the opening. The transverse axis is horizontal because x is the positive term and a is under the x. And then we have a squared plus b squared equals c squared. Now, when we got c in the ellipse, it was a squared minus b squared. This time it's a squared plus b squared. It's very important to note that. So everything is going to be the same when we have y first. The only difference is it's going to open up and down because a is under the y, and so you'll be going a units up and down to get to the vertex. So everything looks the same. We still have that same box. The center is HK. A is the distance from the center to the vertex. B is the distance from the center to one point of the conjugate axis. which helps us get our box, which helps us get our asymptotes. And C is the distance from center to focus. The vertices and the foci lie on the transverse axis. The foci lie inside the opening of the hyperbola. The transverse axis is vertical in this case because it's y first, but a squared plus b squared still equals c squared. So as you can see, if you press rewind and go back, you'll see that everything is the same, except now your vertex and your focus are vertical and it opens up and down.